Total solar eclipses feel like the rarest thing the sky can do. Most people expect to see one at most once in a lifetime, if they are lucky and if they travel. That is true for any one place. It is not true for the planet. A solar eclipse of some kind happens 2 to 5 times a year. Somewhere on Earth, a total eclipse happens roughly every 18 months, at least once every other year, on average, indefinitely. The event is not rare. Your address is. This is not about one eclipse, on one day, seen from one country. It is about why solar eclipses happen at all, the coincidence that makes them possible, the shape of the shadow that causes them, and the rarest of the 4 kinds they come in, which most people have never heard of. None of this works without an accident of size and distance. The sun is about 400 times wider than the moon. It is also about 389 times farther away. Multiply size by distance, and the two nearly cancel. Which is why, seen from Earth, the sun and moon appear almost exactly the same size in the sky. Almost. The sun's disk measures about half a degree across. The moon's, depending on where it is in its orbit, measures a little more or a little less than that. When the moon is close enough, near perigee, its disk is just barely larger than the sun's, and it can cover it completely. That margin is not generous. It is the entire reason a total solar eclipse is possible, and it is thin enough that it can decide on its own what kind of eclipse you get. New moon happens every 29.5 days. A solar eclipse does not. The moon's orbit is tilted about 5 degrees to the plane Earth travels around the sun. Most new moons pass a little above or below the sun as seen from Earth, and nothing happens. Twice a year, the tilted orbit crosses that plane at points called nodes. Only when a new moon lands near one of those crossings does the moon's shadow have a chance of reaching Earth at all. New moon is necessary. A node nearby is the condition that is usually missing. The moon's shadow is not a single dark shape because the sun is not a single point of light. It is a disk, and light from different parts of that disk slips past the moon in different ways. The outer part of the shadow is the penumbra. Stand inside it and the moon covers only part of the sun, a partial eclipse. Deep inside the penumbra sits a much smaller, much darker core, the umbra. Stand there and the moon covers the sun's entire bright face. Only inside the umbra does the sky darken enough to reveal what the sun normally hides. Cross into the umbra, and one of 2 things happens, depending on how large the moon looks that day. If the moon's disk is large enough to cover the sun's completely, that is a total eclipse. The bright face vanishes, and for a few minutes, the corona, the sun's outer atmosphere, becomes visible. If the moon is a little too small, near apogee, the far point of its orbit, a ring of sunlight survives all the way around it. That is an annular eclipse. Beautiful, but never dark. Direct sunlight is visible throughout. Total, annular. Partial, for everyone outside the umbra. 3 kinds most people have heard of. There is a 4th. A hybrid eclipse is total for some observers and annular for others during the very same event. The cause is not the moon changing size mid-eclipse. It is the Earth curving underneath it. The margin that makes a total eclipse possible, the moon's disk just barely covering the sun's, is thin enough that a small change in distance to the moon can flip the outcome. Near the middle of a hybrid eclipse's path, the curve of the Earth brings the ground fractionally closer to the moon, and the umbra reaches the surface, totality. Near the 2 ends of the same path, the ground curves fractionally farther away. The umbra's tip falls just short, and a thin ring of sunlight survives, annular, same eclipse, same moon. A different outcome, decided by the shape of the planet you are standing on. Hybrid eclipses are the rarest of the 4 kinds, arriving roughly once a decade. Most people have never seen one or heard the word. So a total eclipse is not, on its own terms, rare. Somewhere on Earth, the umbra touches down roughly every 18 months. What is rare is that path crossing the place where you happen to be standing. The umbra on the ground is only a couple of 100 kilometers wide. drawn across a planet with a circumference of 40,000. For any single town, a long wait usually separates one visit from the next. That is the actual shape of the rarity, not the event, the address. For the few minutes a total eclipse lasts, something happens that no photograph before or after quite matches. Near the edges of totality, sunlight streams through valleys along the moon's uneven horizon, Bailey's beads. When one bead remains beside the first light of the corona, it makes the diamond ring effect. Then the last bright point disappears, and the corona stands fully revealed. The sun's outer atmosphere, pale and enormous, normally lost in the glare of the disk it surrounds. It is always there. This is the only moment it can be seen without instruments built for the purpose. The light around you can fall by roughly 200 times in the last fraction of coverage. Not because the sun changed, but because the very last sliver of its disk, and only that sliver, was providing almost all the daylight. Every kind of solar eclipse, partial, annular, total outside the narrow path of totality, requires the same rule: never look at the bright sun without proper protection. Certified eclipse glasses or a handheld solar viewer, marked to the ISO 123.112.2 safety standard, are thousands of times darker than sunglasses and are the only filters made for this. Ordinary sunglasses, however dark, are not enough. Neither is an unfiltered phone camera, binoculars, or a telescope. Concentrated sunlight through an optical lens causes injury faster than the naked eye does. You do not need special equipment to watch safely either. A pinhole in a piece of card held so sunlight passes through it onto a second surface projects a small, sharp image of the sun's crescent. No filter, no risk, and the classic way generations have watched a partial eclipse, inside the path of a total eclipse. Protection comes off only once the bright disk has completely disappeared and goes back on the instant any of it returns. None of this is permanent. The moon is moving away from Earth by about 3.8 centimeters a year, measured by laser ranging off mirrors the Apollo missions left on its surface. That is nothing in a human lifetime. Over hundreds of millions of years, it is enough to change the moon's apparent size in the sky. Eventually, the moon will be too far and too small for its disk to cover the suns again. No more total eclipses. No more hybrids splitting one event into two outcomes along a single path. Only the ring every time for anyone still watching. That is where the coincidence ends. It has not ended yet. The margin, the one number this video keeps returning to, still holds narrowly enough that a fourth kind of eclipse can exist at all. An eclipse of some kind still reaches somewhere on Earth every year or two. The event was never rare. It is only running out slower than anything you will notice, and one day it will be gone.